obvious to recognize because you're going to see a trig function in it. And what we're going to do when you have linear and quadratic, you're going to solve it like an algebraic equation. So when you solve a linear equation back from algebra, you want to get that x or y all by itself. But like I said, we're not dealing with x's and y's anymore. What you're going to do is you're going to isolate the trig function. So just like you have to add, subtract, multiply, or divide, again, we're trying to get that trig function all by itself on one side. Our answers are going to be angles. Again, our answers are going to be angles, and we're going to list these angles in radian mode, unless specifically stated otherwise. And they usually will give you a domain restricted. Typically, it's going to be from 0 to 2 pi. Remember, we've talked about the unit circle. You could give answers from 0 to 2 pi. You could give answers from 2 pi to 4 pi, 4 pi to 6 pi. These trig equations have an infinite number of answers. That's why they're going to have to give you some type of domain restriction, and typically it's just going to be the angles between 0 and 2 pi. All right? So again, let's take a look at solving these equations from 0 to 2 pi. So these are all linear, so let's take a look at number 1. Tangent theta is equal to 1. Well, is tangent already by itself on one side of the equal sign? Yes. So I always like to play my trig tic-tac-toe. So I want to know where tangent is equal to positive 1. So remember, you're all students take calculus. Where is tangent positive? Tangent's positive in what quadrants? 1 and 3. So I know my angles can't be in quadrants 2 and 4. So what I want to do is I want to ask myself the question, what angle has a tangent value of 1, and I have to be in quadrants 1 and 3. So that's the question you're asking yourself. So in quadrant 1, what's the angle that has a tangent value of 1? Pi over 4. So one of my answers is going to be pi over 4. What's the angle going to be down there in quadrant 3? 5 pi over 4. Remember, we're not dealing with inverses anymore. We're back to looking between 0 and 2 pi. So you're going to end up with multiple answers for a lot of these. All right, so any questions on where I got pi over 4 and 5 pi over 4 from? So now let's take a look at number 2. Cosine theta is equal to negative square root 3 over 2. Cosine is already by itself, correct? So I don't have to worry about doing adding, subtracting, multiplying, dividing both sides. The question is, I want to know where cosine is negative. So in what two quadrants is cosine negative? In what quadrants?
2 and 4. 2 and 4. No, 2 and 3.
All students take calculus. So we're going to be in quadrants what? 2 and 3. So I'm not looking for an angle in 1. I'm not looking for an angle in quadrant 4. So know your location, know where you're picking the angles from. So what angle in quadrant 2 has the cosine value of negative square root 3 of 5 pi over 6? How about in quadrant 3? 7 pi over 6. You can see, guys, how you have to know the circle. In this chapter, this is where, if you do not know that circle, this is going to be a tough one. So spend some time this weekend, if you need to, getting to know your long-lost friend, the unit circle. Okay? So any questions on 1 or 2? Let's take a look at 3. Now, is sine all by itself? No. So how am I going to isolate sine? What am I going to have to do? Divide by 2. So I have sine of theta is equal to negative square root 2 over 2. So again, let's think about where I'm going to be. So where is sine negative? Sine's negative in what two quadrants? 3 and 4. So what's the angle down here in quadrant 3? 5 pi over 4. And the one in quadrant 4 would be 7 pi over 4. Okay? So now let's take a look at number 4. I have to get secant by itself, so what am I going to do to both sides? Divide by negative 2. So 4 divided by negative 2 is negative 2. Secant's reciprocal of what function? Secant's reciprocal of the cosine. So cosine theta is equal to negative 1/2. if that helps you figure out what the angles are going to be. Change it into a cosine. So where's cosine negative? Cosine's negative in what? 2 quadrants?
Or 2 and 3.
2 and 3. So I know I can eliminate 1 and 4. So what's the angle in quadrant 2 that has a cosine value of negative 1/2? 2 pi over 3. And then the one in quadrant 4 would be 4 pi over 3. So any questions on solving when it's a secant? Like I said, if it's helpful for you, change it into the cosine and take the reciprocal. Okay? Take a look at number 5. So I'm going to have more than one operation to do to get cotangent by itself. So just the same rules like you do for an algebraic equation. What are we going to do first to get cotangent by itself? Subtract. And then I'm going to do what? To get cotangent by itself? Divide by the square root of 3. Now don't rationalize. So we want to know where cotangent's equal to negative 1 over square root 3. Well, take the reciprocal if you want to look at the tangent. What's the reciprocal of negative 1 over square root 3? Just simply negative square root 3. So where's tangent negative? Tangent's negative in what? 2 quadrants? 2 and 4. So I know I'm not looking in 1 or 3. So what's the angle in quadrant 2 where tangent's equal to negative square root 3? 2 pi over 3. And then it's going to be 5 pi over 3. So any questions on number 5? You guys go ahead and try 6 for me. Where is the y coordinate equal to 1? Remember, looking on your unit circle, you've got the ordered pair on the positive x-axis at 1, 0. Up here you've got 0, 1. On the negative x-axis you have negative 1, 0. And down here you've got the ordered pair 0, negative 1. Remember, sine is the y coordinate. So at what angle is the y coordinate equal to 1? Pi over 2. So theta is equal to pi over 2. Okay, so any questions on that one? You guys go ahead and try 7 and 8 for me. So hopefully we came up with, for number 7, pi over 3 and 2 pi over 3. And then for number 8, again, when you add 2 and divide by square root 3, don't rationalize the denominator, because if you change it into the cosine, notice the radical becomes the numerator. So you're looking to see where cosine is equal to square root 3 over 2, which is going to be in quadrants 1 and 4. So any questions on the linears?
So would we ever have to rationalize?
That's just for you to help you identify the angles. So if you need to rationalize to help you find the angles, then yes. But in terms, these are not your final answers. This is just what you're using to help you locate the angles. Any other questions on 7 or 8? So any questions, guys, on the linears before we talk about the quadratics? So now let's talk about algebra land. What's the first thing you always try when you're trying to solve a quadratic equation? You always try to solve by factoring. Exactly, and that's exactly what we're going to do when we're dealing with these trig equations. I've had you practice earlier this semester factoring involving your trig functions because I knew we were going to reach this point. So I wanted you to be comfortable factoring an equation where you had, for example, a sine squared minus 4. We've had some practice doing that because I knew we were going to need it when we got to this section. Remember what I said. Remember when it's a quadratic, what we did earlier? If you need to, you can use a temporary substitution. Remember, as I mentioned, if you want to, what I had you do when you were dealing with those quadratic equations is you can replace an x with a sine or cosine or whatever. If there are common terms or if it's a quadratic, then what you want to do is you want to factor. Remember, you want to check for a GCF first. So all those different factoring techniques that you've learned back in algebra land. All right. Remember, once you factor, you then take each factor and what do you do with it? You take each factor and you set it equal to 0. So remember, we use that 0 product property. Again, just like we did, they're going to give you a domain restriction. So you want to find your angle in radian mode within the domain restriction. Now, with these trig equations, there may be those extraneous solutions or extraneous values where there would be no answer. So in Algebra 2 last year, you guys solved some equations where you had extraneous. Remind me again, what's an extraneous solution?
Something that you can't hold.
You get an answer, but it doesn't work in the original equation where there's no answers. All right? So just like in algebra land, you may end up with some extraneous solutions. So let's take a look at number 1. Sine squared theta minus 1 equals 0. Again, if you need to, you can replace the sine with an x and treat this as an x squared minus 1 equals 0. You don't need to do the substitution. If you can recognize how to solve or how to factor sine squared minus 1, leave the sign in there. How do you factor x squared minus 1, or how do you factor sine squared minus 1? X plus 1 and then x minus 1. So I can factor this into sine theta plus 1, sine theta minus 1. Now remember, when you solve an equation, what do you do with each of these factors? You're going to set each factor equal to what? 0. So sine theta plus 1 equals 0, sine theta minus 1 equals 0. Again, just like I did in the previous examples, you want to get the trig function by itself. So first of all, I'm going to subtract the 1, and I'm going to add 1. So again, these are not in quadrants, these are quadrantals. So where is sine going to be equal to negative 1? Sine is equal to negative 1 at what angle? Now remember, your answer has to be between 0 and 2 pi. 3 pi over 2. Remember, the only time you have to worry about saying negative pi over 2 is when you're dealing with the inverses. All right? Where is sine equal to positive 1? Pi over 2. Remember, at the quadrantals, you're on your y-axis, the y-coordinates are equal to 1 and negative 1. So it's going to be at pi over 2 and 3 pi over 2. Let's take a look at example 2. First of all, is this a quadratic equation? When you solve a quadratic, what do you always want to have on one side of the equation? You want to have a 0. So what's going to be the first step here? You're going to do what? Subtract the cosine. Never, ever, 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 ever. The temptation is, some of you want to divide everything by a cosine. You will lose values nowhere in your life, I hope, an algebra teacher ever told you when you have a quadratic equation, for example, as a 2x squared equals x. Hopefully nobody in your life ever said, this is how you solve a quadratic equation, you divide by x. Hopefully, if a teacher ever did, please pass that information along to me. When you want to solve a quadratic, you always want a 0 on one side. Got it? What will happen if you do this? You're not going to get all the answers. You're going to lose solutions. That's what would happen if you tried that. So that's a no-no. Don't do it. Okay? How do you factor now 2 cosine squared minus cosine equals 0? Take out a cosine or take out an x if you've changed it into x. So I can take out a cosine theta. So I have 2 cosine theta minus 1 is equal to 0. So remember, after you factor, what do you then do? You're going to set each factor equal to what? 0. So I need to take cosine theta, set it equal to 0. 2 cosine theta minus 1 equals 0. So let's talk about where cosine's equal to 0. Cosine's the x-coordinate. So I'm looking to see where the x-coordinate's equal to 0. So I know I'm not in a quadrant. I know I'm on a quadrantal. Pi over 2 and 3 pi over 2. Remember your quadrantals I sketched over here. On the x-axis, it's 1, 0, and negative 1, 0. So you're looking where the x-coordinate is equal to 0, so it's a pi over 2 and 3 pi over 2. Now let's talk about 2 cosine theta minus 1 equals 0. So I want to get cosine by itself, so what am I going to do? I'm going to add 1 and then divide by 2. So now again, what quadrants are we going to be located? Where am I looking for angles? 1 and 4. That's where cosine's positive. So what's the angle in quadrant 1 that has a cosine value equal to a half? Pi over 3. And then the one down here in quadrant 4 would be 5 pi over 3.
What if you just like move it from one wall and left to
I'm sorry?
you're like
Oh yeah, if you made like one big circle. Oh yeah, that's fine. But notice this equation now has 4 solutions. Okay?
Can we just put them all in one line?
Yeah, that's fine.
Wait, so are you supposed to put it back into the equation and find out if it's extremes?
Yeah, you'll see what happens if it's extraneous. You'll see where. Okay? I mean, if you want to check to see if they're right, you can. But the extraneous solutions will come up. You'll see when they come up. Let's take a look at 3. Like I said, if you're not sure how to factor secant squared minus secant minus 2, you can do that substitution, letting x be equal to secant theta, and change it into x squared minus x minus 2 equals 0. So if you need to, do that replacement to help you get through the factoring process. How do we factor x squared minus x minus 2?
X, well, let's x minus 2.
There we go. So we can factor that into x minus 2 times x plus 1. So now you can bring your secant back in. So I have secant theta minus 2, secant theta plus 1 equals 0. So now what do I do with each factor? I take each factor and set it equal to 0. So secant theta minus 2 equals 0. Secant theta plus 1 equals 0. Like I said, you don't need to replace that x. That's only if you're having trouble seeing how you factor it in terms of secant. If you know how to factor it with a secant in there, you don't need to do that step of that substitution. That's just to help you if you need it. So now I need to get secant by itself, so what am I going to do? I'm going to add 2. Well, secant's reciprocal of what? Secant's reciprocal of the cosine. So let's see, where is cosine theta equal to a half? So where am I looking for my solutions when cosine's equal to a half? 1 and 4. So again, the angle in quadrant 1 is going to be at pi over 3, and then the one down there in 4 is going to be 5 pi over 3. So now I need to look at secant theta plus 1 equals 0. So let's get secant by itself, so I'm going to subtract 1. So where is secant equal to negative 1, or where is cosine equal to negative 1? That's going to be at pi. So any questions on that particular example? So you have 3 solutions in number 3. What do you think you're going to have to do in number 4? It's not a quadratic equation, but am I going to divide both sides by tangent? No. Any thoughts on what you could do in number 4? Subtract tangent and then do GCF factoring. So go ahead and try number 4 for me. Again, get a 0 on one side and then you can pull out a GCF. Remember, when you pull out a tangent, it's going to be a minus 1. You don't just drop it because you're dividing tangent by tangent, so you'd have to write a 1. Okay? Remember, you do GCF factoring and you divide something by itself, it's just a 1. Right, and with the tangent on the outside, yes. You don't need to write 0 twice. So 0 and pi. Because, I mean, if you wrote 0 twice, it's not wrong, but you don't need to write 0 twice.
Where did I put pi in?
Now, remember the directions. That's where you want to look at the restrictions. Remember, right here, they want the angles to be 0, less than or equal to theta, less than 2 pi. Okay? So 2 pi is not included in that restricted domain that they're looking for your answers.
But it's 0's up there.
But it's less than or equal to. Yeah, it's less than or equal to. Again, tangent, remember from your unit circle, is the y divided by the x. So y divided by x, 0 divided by 1 is 0. And then if you look at negative 1, 0, 0 divided by negative 1 at pi is also going to be 0. Any other questions on number 4? And again, secant theta is equal to 1. You're looking to see where cosine is equal to 1, and that's also at 0. Like I said, you don't need to write 0 twice. You guys go ahead and see if you can factor number 5. Go ahead and try factoring number 5 for me. So you should have it factored into sine theta minus 1 times the quantity of 2 sine theta plus 1. Again, you may be using, I think we talked about this with the slide and divide. You've got the X method. Some of you were talking about the M method. There's all kinds of different ways that you deal with factoring quadratics where the leading coefficient is not equal to 1. I don't care what method you use as long as you can factor it. So any questions on how I came up with this?
How did you come up with 2 sine A plus 1?
You guys get, again, remember, after you get done factoring, you end up with sine theta is equal to negative 1/2. So any questions on example 5? All right, guys, go ahead and do the last one for me. Go ahead and do your factoring and solve it. And then we're done. So did you guys end up with pi over 4 and 5 pi over 4 for the last one? All right, when you factor cotangent squared theta minus 2 cotangent theta plus 1, it factors into cotangent theta minus 1 times itself. So any questions on solving these types of trig equations?